All right.
Okay.
All right. Oh, I've got to find it again. Let's see.
Hey guys.
Oh,
hey,
there she
you
is.
made it.
Sorry.
Perfect timing. We were just getting started with our quiz, so.
So I have a quick question for you guys. I'm not sure, maybe you've already kind of talked about this, but in the quantitative, what's the name of it? The quantitative inference procedures software, you know, the Excel. So I'm kind of confused as to the difference that Excel sheet creates is like backwards, I think, to what they want. Like it'll make them all positive when they're all supposed to be negative, or vice versa. Do you know, does that play, I mean, does that make a difference in the answers, or?
Yeah, when I was doing homework, sorry, Jen, go.
No, go ahead. Go ahead.
I was going to say, when I was doing the homework, the answers actually said, like if the answer was 1 and 2,
yeah,
it could be -1 and 2 or 1 and negative, or the opposite. So unless they actually tell you exactly how to do the subtraction, you know, then they actually let you do either or. Doesn't matter.
And I saw that, but I wasn't sure if we would get dinged for it, like in the exam or something. So I just wanted to make sure that I did it the right way. If that makes sense.
Right.
Like, maybe both answers are right. I don't know.
As I was reading through the lesson, it said that you want to make sure you take the post and subtract the pre from the post, and that should give you.
So then maybe the
best way to do
that is to copy the post and put it in the first one, and then put the pre in the second one.
Or however you have it set up.
Okay.
You know.
Because I know the Excel data sheet, whatever the equation that it's automated to, is going to. So I guess I should just look at that, and I'll just keep in mind that it should always be post, subtract, pre, right?
Yeah, pre, subtracted, post.
Perfect.
At least that was my understanding from the lesson.
That's what I understood too, and it seems like I don't know. It seemed like when I did it, I just made sure that I put the right column in the, you know, the before column and the after column, I guess. And
okay.
So.
Alrighty.
I don't know. So. Okay, so. All right. So we need to open up the data files, it looks like.
I'm a little slow and haven't quite gotten there yet.
Okay.
Been ages since you've been here. Jared, I found out how to make stone spheres. Oh, it looks really cool. Check it out, our water's still going.
Okay, so are we ready?
Yeah, I think so.
Yes.
Okay. So do we need to open up? We don't need those files.
Okay,
do
sorry.
we?
No.
Oh. Okay.
Is everyone on question 3 at the same spot?
Yeah.
Yep.
All right, so suppose we have a set of paired data and let D equal X after negative X before.
So just the after minus the before.
Oh, I see. After minus before, gotcha. The null hypothesis equals 0 and the alternative hypothesis is not equal to 0 and the population standard deviation is not known. Jordan collects a sample of size n equals 9 and computes d bar equals 2.2 and that's the standard deviation. What is it? The sample standard deviation of the difference or something like that?
Yeah.
All that SD equals 3.3. What is the value of the test statistic?
So is that D?
So we're solving for T equals, and then remember it's D bar minus 0 divided by
the
3.3 divided by the square root of 9. So 2.
So 2.2 divided by.
Did you guys get 2?
Yes.
Yep, 2.
So the test statistic on that one is 2, okay? The probability of obtaining, did everybody understand how, sorry, I shouldn't move on yet.
No, you're good.
We're on the same page there? Okay. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test, round to 3 decimal places.
So can we use the probability applet for that?
I'm kind of confused on this one.
They have the applet up above so that you can open it.
Oh,
I would imagine you can use it.
So we must have to use that then, I'm assuming.
but the distribution applet, doesn't that just show, yeah, that just shows the degrees of freedom, right? Oh, no, I guess it doesn't. So what was the 0.0403?
So I think we put that in the bottom
Yeah,
part.
0.0403.
In order to get it correct, we would need to know the degrees of freedom, and they don't give that to us, do they?
Yeah, it would be 8 because it's a sample size of 9.
Oh, that's right.
So then would it be 0.969?
That's what I have.
Okay, so how did we get that?
So we put that
So-
p-value down at the bottom in the 0.0403. And up at the top, we have it with 8 degrees of freedom.
And how do we figure that out?
Because the sample size was 9 and the degrees of freedom is just n minus 1.
Okay. And then because it says greater than, are we supposed to shade just on the right side?
Oh,
Yeah.
yeah. So that would make it 4.484 or 0.486.
0.484 is what I have on mine.
For 0.485, I guess, is what it would be.
Well, mine says 0.4844. Oh, why does it?
Mine says too.
This number on the bottom goes to 3 decimals, I think. So, it's like
So
mine
I
says
put
0.0.
0.0403. Is that what? Did you
Well, I put that in, but it changes itself.
Oh, yeah. Mine
Yeah.
just changed.
Mine did too, to 0.040.
Yeah,
Right.
and then it just changed my area to,
0.969 in the area box.
well, that when
So-
you have both the left and the right shaded, it does. But this, it's asking for greater than.
Oh, let's see here. The probability.
Is it? Or is it
Uses
just?
probability to determine test. Where does it
Oh,
say
it's not
greater?
asking for greater than.
I think this is like a two-sided.
But it
Test.
says the probability of obtaining a test statistic greater
Greater than.
Jordan's test.
Okay, so I think you're right. I think we're only going to want to highlight the right side.
Right. Okay.
Yeah, so that's 0.484.
So
Okay.
0.485, I think it'll round up.
Mine says
Yeah.
0.4844.
So does mine.
Oh, mine says 0.4845.
Mine did too, but then when I went back down and changed I typed in the T-score again,
Uh-huh.
and then it changed it to 0.4844.
Okay, perfect. Then let's go with 0.484 on that one.
Okay.
I'm glad you caught that, the greater than, because I did not. I looked right over that. Perfect.
Okay, so now we have to open up this file. And we'll have to open up the other inference, right?
Yes, I think so. See, so do you keep group 1 and group 2 the way that they are when you copy and paste these?
I
do.
put the before in variable 1 and the after in variable 2.
This one
So
doesn't
what-
really have before and after, has group 1 and 2.
Exactly. So did
What?
Let me move this over.
What am I looking at?
Be sure that the test does group 1 minus group 2, is what the question says. So we want
Does-
group 1 minus group.
so then is your first difference negative 32.1?
Haven't gotten that far
It
yet.
shouldn't be negative, right? Oh, yeah, it should be negative. Group 1 minus group 2.
Okay, perfect. So we're doing level of significance. Equal to.
So group 1 minus group 2.
And then our confidence level will be 0.9
You're way ahead of
because, okay. Sorry, I'll pause a minute.
me. I'm just barely getting mine put in there. Is there just, how many rows are there? I mean, how much? I didn't go down all the way. So do you just have 20?
23.
I think there's just 24.
24
Okay.
lines?
Down to 24, so n equals 20.
Yep, it
Okay.
equals 20. Sorry, because I guess that doesn't start until line 4.
Command C, me do command. Oh, but it's not putting my, it's not doing my, I might have to reload my inference. So if you guys want to keep moving on without me, that's okay. It's not calculating a difference.
Did you
Oh, really?
guys just,
Yeah.
Weird.
But
you guys found the difference and then pasted it into the one sample t-test for means? Is that what you did?
Say that
With-
again?
So you find the difference, and then you take that and paste that into the quantitative inference.
It should
Page.
calculate the differences for you in the Excel sheet.
I had to set mine up so that it would do that. Have you done that yet?
Yeah, like I have all the differences done,
Okay.
and then I just take that list and paste it into the other
Yeah.
one.
If you can do it that way, or you can set up the quantitative inference procedure thingy to do it, and then just paste in group 1 and 2, and it'll automatically do it for you. As long as you paste your groups in the right place, right order.
So I never set anything up, but it just automatically does that for me.
You didn't have to do a little like equals and then
Uh-uh.
pick cells you were going to subtract it from?
I
And stuff? Really?
Yeah, it just did it for me.
well,
So hopefully
really?
the numbers are right and everything. I mean, they look right.
and is this a paired sample test or
Yes.
a 2-sample t-test?
I believe
This
it's
is
a
the
paired
pair,
sample.
right?
Yeah.
I hope so.
That's
Well,
okay.
I think a paired sample
'cause you're
test is
subtracting.
when you're working with the same population, like fathers and sons, and then I think 2 samples will be completely
Oh, it
different.
says perform a paired sample t-test. So, okay, if I just would read, sorry.
You're okay.
So is it in the paired sample or the 2-sample?
Paired
It's just
sample.
paired. Okay, so I'm so dumb. So I just take the differences and I put it into the 1 sample because essentially that's what it is.
Yeah.
I don't copy and paste my variables 1 and 2. I just do the differences into the
So
1.
how do you get the differences?
On the spreadsheet, I just go 1 column over.
Ah, so
And-
smart. And just do.
I click on that and do your formula
Okay.
and then drag it down. And then I just take that 1 list.
Yes.
I don't do all, I don't do the
Okay.
2.
Okay.
I think they're both good ways
It's
to do
the
it.
same thing. Okay.
But-
Okay. So what's our question here? What's the test statistic? So I get 0.407. Is that what you have?
That's
Yes.
407.
0.407. Okay. And then the p-value,
0.689.
9.
Yep.
Okay. Let's see. So we fail to reject the null hypothesis. Are we doing a 95%?
We're doing a 90.
90? Oh, okay. I need to change that.
Well, I'm pretty sure just because the alpha is 0.1, so I think that would be
Yes, you're right. It's 90.
Yeah.
Okay.
So we fail to reject it, right?
correct.
Oh, greater than.
Oh, we fail to reject the null hypothesis. So number 7 is fail. Okay, suppose you're greater than 0.
So that
So
changes
change
the
that.
p-value.
Changes to greater than, so then we'd still fail to reject it, right?
Suppose your alternative hypothesis is instead. Yes, so we would still fail. So we would have insufficient evidence that the mean of the difference is greater than
Greater
0.
than 0. Yeah. Huh, now we have to get a whole nother thing of data. It's all over again. What the heck? Okay.
Oh, crap.
Okay. And this one's going to be a 99%.
And you said it's 95, right?
99.
99.
It's a 0.01, so.
Okay. And a not equal to.
And not equal to?
Yeah.
Okay. All right. So
N is 20
Always
again.
going to be greater than, because isn't
are we on
is
number 9,
-1?
which is greater, N or DF? N is always greater.
Correct.
Okay. Sometimes when they ask those questions, it just, I think, I must be wrong. That seems too easy.
It can't be that easy, huh?
Yeah. Okay, so my p-value, I have 0.001.
I've got 0.005.
Uh-oh.
I got
We're
0.001.
Okay.
I got 0.002.
Okay, I see. I need to drag my thing down here a little further.
Oh no, I got 0.001.
Okay. Whew.
I've got 0.001 now too.
Okay.
And me too, right?
Yeah, 0.0012. Okay, and what decision do you make? To reject the null hypothesis
Yes, because the P is lower.
is lower than 0.01. Okay, so now we do greater than.
Got it? Oh. Ooh, great jet.
And we still,
Like the p-value decreased when we did that.
yes.
Keep taking off, dude.
So we still reject.
The null.
No. So what was it? It decreased, right? Yeah.
Yeah.
Yep.
We have sufficient evidence that there is a mean difference. Is that the
Well,
question? I don't know. What was the question?
I think they are wanting us to use the one where it's greater than 0.
Oh, okay.
All right. From the previous question.
Just a
So we have
conclusion.
Oh, let's see. Okay, these are worded. Okay.
Yeah, I think that there's, is it the third one?
I would think so, because there is a mean difference and we have sufficient evidence for that,
Correct.
right?
Yeah,
I also think it's the third one.
okay.
okay.
Seen.
Ooh, that was worded a little bit tricky there.
Yeah,
That was different. I've not seen it like that before.
Okay, so as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
I think it's the greater than 0.
Get out here.
Yeah.
Do you want me to
We can
do it
always
in
test-
really fast?
Oh, yeah.
Yeah, sure. I mean, we can
Okay, so
just put less than. Yeah, it's greater than.
Yeah. It's greater than.
Are you guys leaving?
Yeah.
Okay, love you.
wait a minute here.
See ya.
It's asking which one will give us the smallest, correct?
Uh-huh.
Okay, so it's definitely not less than.
No, if you just go up
Yes.
there and change that to greater than, it's going to give you a smaller p-value. And
Yep. So we're going with D.
yeah.
Determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2.
So
From
you
what we
just change
just
it to
did.
65, right?
So what is the point estimate for this? I guess I don't understand that
Point.
question. Is that the confidence interval subtracted the high from the low? I don't know what that is.
Okay, so well, let's go to the thing and put in 0.95.
Right.
Is your guys' confidence interval 5.303 and 18.607?
Uh-huh.
Yeah.
And then it's asking us for the estimates.
I guess I don't know what the point estimate is.
Estimate.
I am not sure either.
Would it be the mean?
Well, I'm wondering if it's the, I don't know.
Well, let's find out.
Let's see.
I don't think I have anything about a point estimate in my notes.
So,
Oh, it's D bar.
Which would be the mean, right?
Oh, okay.
Bar.
so the point estimate is D bar.
So which it should give us D bar in
Would be 11.95, 955.
yes.
Okay.
How much are we supposed to round that to?
Well,
It doesn't say,
at
so
the beginning, it says to round everything to 3.
yeah.
3.
So 11.955.
Okay. So the point, I need to write that down.
And we're still doing it with just the greater than and not the different than, right? Because that was the last thing that they had us change it to.
That's true. I need to make sure I have the right thing in there when I do
Yeah,
that.
I have less than actually, but maybe that doesn't change the,
I don't think that does change that
Change.
actually.
I think it only changes the differences or the,
It only changes the p-value is the only thing that changes for that, I think. Yeah.
yeah.
But I do think we are on the greater than though still, right?
Determine
what
the
I-
95% confidence interval for the mean difference between the two.
What is the margin of error?
Fly.
5% confidence interval. Okay, so is this when you take the confidence interval and you subtract them from each other and divide it by 2?
The
I
margin of
think
error.
so.
Uh-huh.
Yeah.
I think so.
I think that's what we were kind of having a problem with on that last quiz.
Yeah. Minus 5. 0.303.
So we take the higher one and subtract the lower one, right? Take the one on the
Right.
right, subtract the one on the left. I got 13.304.
That's divided by
Divided by
2?
2?
Oh, then we divide it by 2? Sorry,
Uh-huh.
I'm out. Okay, 6.652.
Yep.
Yeah, that's what I got.
Yep. So 5.303 on 18.
Input the lower bound. It looks like 5.303.
Uh-huh.
What's the lower bound? Oh, the
Low
confidence.
end of the confidence interval.
Like, what are they talking about?
I know, that's why I'm confused. I'm like, I need somebody to just straighten out all the vocabulary for me.
Yeah, that's half the battle, isn't it?
I think so, yeah.
Upper bound.
And then did you guys get 18.607
Yeah.
for the upper bound?
Yeah.
All right, I'll go ahead and submit it and see how we did.
You're such a gem for doing that first every time.
You are.
All right, let's see here. We got, shoot, guys, we got an 18 out of 20.
So
Oh.
which ones are wrong? Does it tell you?
Yes, it does. So we missed number 15.
Which one?
15?
Number 15.
Really?
Okay.
And we missed, well, let me just tell you what I put for my answer, because maybe I put the wrong one down. I put D for 15, and I got it wrong.
That's what I put.
Yeah.
And then I got number 4 I got incorrect. And I put 0.484.
Number 4. Let me go back there.
That's
what
that
I have.
probability thing.
Huh.
Interesting.
Oh,
Okay.
I put it in the T probabilities, and it's asking for the p-value.
So we would use that other applet.
So why didn't they give that
Wait a
to
minute.
us, to you?
But the p-value
doesn't-
was 0.484. We put 0.0403 in the t value.
Yeah, which we should go.
Okay, let me look again.
The probability.
So
Let me test this.
I do know in that applet that I feel like we did that right, because the p-value always goes in the area box once you put in the
Yeah, that's true.
score or the t statistic or whatever, it goes in the bottom. So maybe we don't do one side. Maybe it is both sides. But it does say greater than.
Or would it be, if it's greater than, it would, yeah, it's just that right side.
Maybe it should have been 0.485 like you were getting before. I don't know.
Yeah.
I think Mindy's going to come get you pretty soon. Or you have football. Here.
Oh boy. Let's see.
I wonder what happens if we put it in like the normal probability applet. The same 0.4840 with that one, so.
0.0403.
And it's not -0.4.
Well, okay, hang on. The probability of obtaining a test statistic greater than Jordan's test statistic is...
I don't understand why it would be wrong.
It's got to be 0.484.
Probability of obtaining...
The only other thing that changes that is the degrees of freedom. And
So did we put the wrong degrees of freedom then?
But it says that the sample size is 9.
It's 8. Degrees of freedom should be 8.
That's what I had.
That's
that's
what
what
I
I had too.
Oh, I didn't have that.
Yeah.
And now I get 0.516.
What?
Yeah, so when I have, in the bottom I have, it won't let me put 0.0403. It just keeps it at 0.040.
Uh-huh.
Right.
And
0.03.
Oh, hold on a second. Okay, and then I put 8 degrees of freedom. Oh, crap. Hold on. My numbers just all disappeared. Let me re-input them. Okay, we've got 0.0403. 0.0403. Enter. Oh, that's perfect. Thanks, Nat. Okay, thanks, Nat. Okay, so I put the numbers back in, and I put 8 degrees of freedom, and I still got 0.484.
Yeah.
Yeah.
I don't know what I did before that changed it, because that was weird for a minute. I think I had the middle part highlighted there for a second. So,
Huh.
dang it.
So I never wrote down the, yeah.
That one's a stumper. I really don't know what to do different on that one.
I have no idea.
Well, so I guess, let me go back to the question. The test statistic is... I feel like the question is not, okay, Jordan's test statistic. And that is just the t value, right? Because
Yeah, like the t-score, the t-value.
so I guess the thing is that we got a test statistic of 2. And so when we
Right.
did that, and so the probability of obtaining a test statistic greater than Jordan's is 0.043.
Maybe they're saying greater than so that we know where to put in the 0.0403, but they still want us to check both sides as though it was not equal to instead of greater than. Maybe that's,
That's the only thing I could think of on that to change.
Yeah.
let's try that.
What if
So we'll have somebody else turn in the test this time.
I can do that, but let's go ahead and do 15 at the same time.
Yeah, for sure. So we would change that answer then to 0.968 or 969.
0.969, I think, is what we would
Yeah.
change that one to.
Yeah.
Okay.
Okay.
I can't believe we got 15 wrong. We're sitting there actually doing it.
Yeah, I don't understand that.
Okay. Down here.
Value.
Hey, maybe there's not enough information. Maybe it does depend
That's
on the numbers.
That's what I'm wondering, is if there's not.
That's what I would think, because you know it's not A. It can't be A, because A is sides. And maybe the difference on the two sides depends on other information that isn't in that question.
Yeah, that would be my next best thing. So whoever's going to submit now, I would put 0.969 for 4 and then put C for 15, and let's kind of see what happens.
Okay.
Okay, I can do that.
Are you doing that, Jen?
Yeah.
Okay.
And my computer's going slow. Do you guys have to like hit submit 3 times before it actually submits?
Yeah.
Yes.
Now it's saying 19 out of 20.
So,
Okay. We got one right.
We got 15 right, apparently, so it must
Okay.
be.
so 4 is still wrong?
Yep, 4 is still wrong. 0 out of 1.
Oh my God.
That is so weird.
The probability. So is 2, I think that we need to be using the value that we got in the previous answer, do we? As our test statistic?
You think? Well, that would that be T then? 2 would be T.
T equals 2, yeah.
2.
We could try it.
And then it would be greater than, it would just be that one side. And I get 0.040. So I'll put that in mine and submit.
2 attempts turns into
4.
yeah.
8.
Okay, so that's the probability that we end up, the probability of obtaining a test. So that's what's in the area, is the 0.040 that they gave us. Use this probability to determine the p-value for Jordan's hypothesis test. So we should have known, because that's the probability is the p-value, right? Duh, I can't believe I didn't remember that. P-value is the probability of obtaining a test statistic greater or different than, right?
Right.
So yeah,
Right.
040. We didn't even have to go to the
To the thing.
I can't-
Okay, I'll submit and check it out. So we'll
Wait
see.
a minute. So what are you saying?
P-value, the definition of p-value is the probability of obtaining a test statistic
But
greater
it's still
or
wrong.
different than, more extreme than the one that you got, right?
So,
Right.
but that's still wrong.
Seriously?
Yeah, 0.040 is still wrong.
Still wrong?
Yeah. I don't know. Do we just take the 19 out of 20 or do this one more time? Okay.
Well, I have one more chance. I have
Yes, you do. Yeah. Okay. So
403.
probability.
Okay, so if the probability is the p-value, you put that in the area up at the top, 0.0403.
Mm-hmm.
And then it gives you a t-score of 1.999 when you shade on the right side.
Which is
Okay,
2,
so-
which is what we
Are
came
we
up
supposed to round for that question?
round to 3
Yeah.
decimal places.
So 3 decimal places. So the answer is going to be 1.999.
Or 2.
Yeah, but that's the test statistic. It's not.
Yeah, I know. Okay, the
P-value.
probability of obtaining.
Okay, I got to go through all these again.
I can just read them off to you guys. I've already written them all down.
Okay.
Oh, you are.
Okay, so a p-value is a number between 0 and 1.
Oh, really?
Like 0.05.
Which is, I mean, all the answers we've been getting have been between 0 and 1, haven't they?
Yeah.
Yeah, they have.
Okay, the probability
So, but 1.999 wouldn't.
No, that's
would not be right.
That one I don't think
That's-
would work.
No.
Okay, what's the answer to number 5?
Hang on just a second. Let me pull up my.
5 is 0.407.
0.407.
Oh my heck, girls. I've never had this problem.
Hold on, I'm going to catch up to you real fast, Jennifer, and then I'll go right along with you.
Okay, sorry.
No, you're fine.
Yeah, so I'll need you to tell me. Okay, so true, true. Okay, so number 3 is 2.
Yep.
Okay, and then I'm leaving 5 blank or 4 blank. Okay, 5 was 0.407.
Yep. And now I think, are we all on 6 and I can start reading them?
Yeah.
Okay, so 6 is 0.689. 7 is A. 8 is B. 9 is A. 10, 0.001. 11 is A. 12 is B. 13 is A. 14 is C. 15 is C. 16 is 11.955.
Statistic.
17 is 6.652. 18 is 5.303. 19 is 18.607.
Okay.
Thank you, Erica.
Thanks.
Mhm.
Okay, so we're still working on p-value on 4. Let me.
Yep. You know, I wonder if they took into consideration that we can't put the 3 in.
That we can't do what?
That we can't put the 3 in at the end of 0.403 because that will change.
Oh,
things.
yeah.
You're right, because it doesn't let me do that either, and I wonder if that does just change a decimal here or a decimal there or something.
And we originally, we had gotten 0.485, right?
I had something like that. I think so.
Yeah.
I think a couple of us did.
That's what I had gotten the first time, and then it changed my answer.
What was the t-score again on that? 1.99?
No, well, we put 0.0403.
That's not the t-score. Is it?
Yeah.
Yeah.
It is? Okay. So point.
But it won't let us put in that 3 at the end, which we're wondering if that has something to do with the p-value. Oh, man.
Okay, so I went to a t-distribution calculator.
Mm-hmm.
So I put in the degrees of freedom is 8.
Okay.
The t-score is 0.0403.
Uh-huh.
And it has something called a cumulative probability. I don't know what that is, but it's 0.5156.
Huh.
I don't, a cumulative would be it's adding something else to it, I think.
I know. That's what I think too.
So the probability.
But I wonder if that's the difference, though, between that 3 being at the end and making that probability just be a little bit bigger. Like if the answer really is 0.516. I mean, I don't...
Well, I could type it in mine and see.
I've found something on the math book thing that I'm sending to you guys. I don't know exactly what it means. And I don't know if it will help. But the question, it says, find the p-value and compare it to the level of significance. And then it gives p-value equals SIG, two-tailed, and this is in this week's lesson. So, and then divided by.
Yeah.
So I'm not exactly sure what SIG, two-tailed is.
Is that the significant, the level of significance?
Okay, so the two-tailed level of significance, divide that by 2. And then that gives us the p-value, apparently.
So,
Now,
We could try that.
Isn't that what we did the first time?
yeah, I mean, that's the same thing. Yeah, it would be 9.681 divided by 2, right? 0.9681 divided by 2 equals 0.484.
Oh, man.
Okay.
We might just have to take a hit on this one and then email her and just say we
what were we supposed to do?
thought we knew what we were doing on this, and we don't.
So we're looking for the p-value, right?
Uh-huh.
Which is in the area. Okay. Yeah. Never mind.
Then.
That would, okay, yeah, 4844, shoot. And I thought I was onto something, but that just doesn't make sense. It should be the 484.
It really should be. Like, everything we've learned up to this point, I'm like, I don't know, I feel really confident that that has to be it. I don't know what we would be doing differently.
Yeah.
I think we should just put that, and then we'll just have to ask her.
Let me look and see if there's anything on the discussion boards or if anybody else has had problems
Good idea.
with
Okay.
this one. Let's see, we're in week 7, right?
Yeah.
Yeah, lesson 12.
Lesson 12. Oh my gosh, there's people already done with lesson 13.
What?
I am
Yeah.
so glad you guys are not trying to, get me to be done with lesson 13 already.
Let's see. I think these people are just getting their check mark. Yeah, they are. They're just getting their check marks. So I don't know. I can maybe look at. Okay, let me fast forward through there.
It just doesn't. It's hard because the p-value is the probability, isn't it?
Yeah, the p-value is the area to the left of t under the curve. That's what this is saying here.
Yeah.
So I can't imagine what's wrong unless
Unless she wants us to put it, no, because it says round to 3 decimal places. I was going to say maybe she wants us to put it as a percentage, but
yeah.
wants us to round it to 3 decimal places. So I think I'm just going to put 0.484 and I'll take the 19 and then I'll just shoot her an email that says we sat for a really long time and tried to figure out question number 4 and we don't know how to do it. Can you help us?
Okay, hang on just a second. Okay, I'm watching another groups. And he's like, but 0.4844 because you can't put 3 more.
Yeah, see, they're
So
getting
they're having the same problem. Okay, they're having the exact same conversation. So I think let's just take the hit.
That sounds reasonable to
Yeah.
me.
Maybe there's just a problem in the
Yeah.
answer.
Yeah. I mean, it's the exact same conversation.
So 0.484.
Mm-hmm.
Yeah.
Okay.
Well, I'm not going to resubmit it because
If you've already got the
Okay.
19, then
I've
yeah,
got the
you're good.
yeah, or whatever the score was.
I'll take the 19 over the 18 in a heartbeat. Any
Yeah,
will
that's
help
right.
me.
Yeah.
Oh.
Or maybe I have to because I started it. I have to finish it now.
So what did you guys put for question 8?
Let me look.
B.
Oh, shoot. B is in boy.
B is in boy. Oh no, did you think I said D?
Well, I got it wrong, so I just. Oh, brother.
I'm sorry.
That's okay. I can go back and fix that.
Oh good, so that wasn't your second submission?
No, that was my first.
Oh good,
Yeah,
that makes
'cause
me feel better then. Okay.
I was thinking I still had time to
Yeah. So
try.
that's crazy.
Well,
Holy.
Okay.
can I just shoot Sister Cook an email or should we?
I can put it in because she does check each one of these broadcasts and she always responds. So I'll just put it in our link that
Sounds
we
good.
did that. So, and make sure yeah. So, okay, I stopped the broadcast. All right. So we're good to go. And thank you so much for being flexible for today. I'm very, very grateful. I appreciate it very much.
You're
No
welcome.
problem.
Okay. And we'll see you
welcome.
Thursday morning.
That's right. Yep.
Okay. Take care.
See you guys.
Thank you.
Okay. Bye-bye.
Bye.